Before starting the lesson for arithmetic, let's do some practice review for this lesson. So we can start from the first ones to simplify the expression, which contains a mix of multiplications, additions, subtractions with several brackets. So recall what you have learned in the order of operations. When you calculate a complicated expression, you would first observe if there's any brackets, then you should perform the operations within the brackets first, and then you should then perform the multiplications from left to right, or multiplication division from left to right, and then subtraction addition from left to right. So, and here, if you see multiple layers of brackets, the better to observe your expression carefully at the beginning to determine where is the beginning of a certain brackets and where's the end of a certain brackets, just in order to making sure that you're not doing the calculation within the wrong brackets. So first of all, here, like I see two layers of brackets. I see one at the beginning, and I see this one ended over here. So which means within this pair of brackets, I have a long expression here. And then I have another bracket or another expression here multiplying the first item. So then let me do the calculation within this large brackets first. So I'm going to keep the same large brackets, but let's do the multiplications inside the smaller brackets. So here 1 times 2 is 2, plus 2 times 4 is 12, minus 30, plus 56, right? So this is within the larger brackets. Also the second brackets, you have 9 times 0, which is 0. Okay, so then you can, of course, keep going with the operations of addition, subtractions from left to right to derive the outcome of the first expression, and then multiplying to the second expression. But in the other way, if you already see that there's a 0 multiplying to another number, then any number multiplying 0 is always equal to 0. So I don't even need to finish the calculations inside the first brackets by just knowing that this any number times 0 is still 0. Then I can get the solution right away that it's just equals to 0. Okay, let's see the second question. So what is this? The first expression minus the second number in the second expression. So here again, looks like we need to simplify both expressions first to get two numbers, and then take the subtraction or take the difference between the two numbers to get your results. So first of all, again, by observing your expressions before, like always observe it before you start actual calculation, because you will see you will need to, for example, locate the location of brackets to determine which number within which brackets you're gonna do your calculation first, right? Like for example, in the first expression, I only have one bracket here. It's just in order for a negative number, so it seems okay that I will do the multiplications first, and then we'll do the addition and subtraction from left to right. And then in the second expression, I see a bigger brackets that groups most of the expressions numbers in the first part, and I have a multiplying 0 as the second term of this expression. So again, like this give me right away that the second expression will equal to 0 anyway, because you multiplying the 0 on any number is 0. So this saves me half of the time that I can just forget about the simplification of the second expression, because it will be 0 anyway. So then we can just focus on the first expression. So let me just copy it down here. Then we can start doing the calculation. So first of all, we will do there's no additional brackets, so then we'll move to the next step that will calculate the multiplication first. So I'm still copy down the plus and minus. Now 6 times 6, I need to calculate this first. So 36. And then I need to do the multiplication here. Like here again, like you can do the multiplication of 3 times -1, but right after that, you will multiply another 0. So it will simply goes to 0. Then I finish all the multiplications now. I only have addition and subtraction left. So I can now do it from left to right. So 42 plus 7 is 49, minus 36, plus 0 is just 0. And then this subtraction is 13. So you just get a 13 from the first expression. The question is asking you what is the first term minus the second term. So it's the first term, which is number 13, the second term equal to 0. So eventually it will still equal to 13. Okay, let's see this next question to simplify this given term. So it's still the similar question that we had, that in order to simplify this, we would need to perform all the operations given within this expression, and we need to strictly follow the order of the operations. So first of all, let's check all the brackets. So we have small brackets, which are just in order to separating the positive and negative numbers. We do have one large bracket starting here, ended here, so which means the numbers or the expressions within from here to here will be becomes one number and will be operated first. So let me copy down the first number, minus 20 times, so I would times a whole term inside here. So let's do the first multiplication. So then we should then start doing the multiplications before any subtraction or addition, right? So the multiplication of the first two numbers, like recall that multiplication with multiple signs. If we have negative number multiplying another negative number, you will get a positive outcome. So minus 3 times minus 15 will be equivalent to 3 times 15, which is 45. So I'm just skip one step here. And similarly here, you have a negative sign and a positive sign. Then the outcome of this multiplication should still be a negative number. So which means minus 6 times 3 should be a minus outcome. And then 3 times 6 is 18. So the result is minus 18. And then I'm going to just write one more step to simplify this. So 45 minus a minus 18, which is equivalent to plus 18, because you are minus a negation of number of 18, which is equivalent to plus the number of 18 itself. Or simply remember this relation, that the negation of a negation is this number itself. Right? So then it's really just to simplify further by taking the addition of this two number, which is 63, and then eventually one more step of multiplication with between a negative number and positive number. So your outcome should always be a negative number, which is 1260. So it's negative 1260. Okay, the next question over here, again, the same question too. simplify the following term. So first of all, let's observe the brackets. We have one layer of brackets here and here, and then I have small brackets here. It's just in order to separating a negative number. So then let's keep the outer layer of the brackets first. So 6 divided by -3, right? Positive, negative, so I have a minus sign in front, and 6 divided by 3, right? And here 4 minus 12, it's just minus 8. And then this I can first simplify because 6 divided by 3 is 2. It's minus 2 times minus 8. And then negative, negative become positive. So it's just 2 times 8, which is 16. Next question. What is the value of 123,123 divided by 1001? So in other words, to calculate 123 divided by 1001. So of course you can use, if you learn long division, you can just use a long division to derive the final answer. We can show that at a later step. Actually, before that, without using long division, I'd like to show some other tricks that by taking what we just learned about the multiplication distributes over addition to help us solve this question in a simpler way. So what I just mentioned here is that because the number 1001 is equal to 1000 plus 1, and either the number 1000 or the number 1 is a simplified form that can give you the answers through the multiplication directly. So if I can express 1001 equal to 1000 plus 1, this seems can help me to simplify my question. And we are going to take or to use the conclusion that coming from the multiplication distributes over addition. Now we still have to convert this question a little bit because we're looking for the quotients of dividing 123,123 by this number. So this equivalent to looking for, maybe let me replace with the symbol x. So this equivalent to looking for the number of x such that x times 1001 equal to 123,123. So then if I rewrite this number into 1000 plus 1, then I'm having x times 1000 plus x equal to this. And this is also due to the special form of the number on the right hand side. It's repeating every 3 digits. In other words, it is repeating like this. And then the first number 123,000 can be then written as 123 multiply 1000 and plus 123. Right. So in this case, you probably already seeing this directly that x is equivalent or equal to 123 because all other components are equal to each other on both sides of the equation. Right. Or if I'm writing this one more step, I'm taking the common factor of 123. This is basically the reverse operation of this multiplication disputes over addition. So I'm doing the reverse way by factoring out the multiplication of 123 at the beginning, and then I have the addition left within the brackets. and it is 123 multiply 1001, right? So this is the other way that to show that the answer is 123. So you can verify this by long division by yourself at a later time. Okay, so let's see the next question. So assume that Sean adds up all the even integers from 2 to 500. Inclusive means it's including the number 2 and number 500. So it's Sean's adding all the even integers up to 500. And Julie is adding up all the integers from 1 to 250 inclusive, so it's also including number 1 and number 250. 3 plus 4 plus 250. Now, what is Sean's sum divided by Julie's sum? So we not only are looking for the sum, but we're looking for the ratio or the division between the two sums. So of course, one way you can find or you can calculate the sum of each people first and then take the division, but this seems like complicated because you need to do the summation first. Or if this is only asking for a ratio, maybe we don't have to solve or to calculate the entire summation if we can find a relationship between the two sums. And apparently, if you compare, if I'm listing the two expressions side by side and comparing the numbers side by side, you would probably see the pattern right away that each number that Sean used is 2 times of the number that Julie used. So in other words, if there's a common factor of number 2 from Sean's expression, 100, right? So that if you're factoring it out, it's 2 times 1 plus 2 plus 3. And what is the last number? The last number should also be the number of 500 factoring out number of 2, which means it's 500 divided by 2, that is 250. And now you can see this is just happen to be the same sum that Julie has for summing all the integers from 1 to 250. So writing this back here, so the sum on the numerator is 2 times of 1 plus 2 plus 3 plus 250. And the one on the denominator is just 1 plus 2 plus 3, also up to 250. And then this is just as simple as these two terms are exactly the same, so they can be divided, or like we usually just say cancel out. Cancel out means they can be divided by each other and equal to 1. Right? So eventually the result is 2. Basically, Sean's sum divided by Julie's sum is equal to 2. Right? So in this way, by observing the question, you don't have to take the summation of the entire expression. You don't need to spend your time on that. You can just find the pattern and then simplify it in an easier way. Okay, next one, take the summation of 5 plus 10 plus 15 plus until 95 plus 100. So first of all, let's observe this expression to see if there's any chance that we can simplify it or any chance that we can find the pattern. And because obviously you're not going to really adding up all these numbers one by one. It's going to take too much time. So first of all, I can see that there's a common factor of 5 from every single number here, right? So which means the first step, I can simplify this expression by taking out the common factor of 5. So then it's equal to 5 times 1 plus divided by 5 is 2, 15 divided by 5 is 3, until 95 divided by 5 is 19, then the last one, 100 divided by 5 is 20. So first of all, I can simplify this expression into 5 times the summation from 1 plus 2 to 20, right? Now this becomes a bit easier than the original question already. Now, how to calculate the sum to 20? Again, you don't have to really add them up one by one because it's taking too much time. You can still try to observe if there's any pattern that you can find. In fact, if I'm gonna write a couple more terms at those beginning and the end, you will probably see that number 1 and number 20, number 2 and number 19, number 3, number 18, if I'm adding up first one with the last one, and the second one with the second last one, the third one with the third last one, they seems all equal to each other. 19 by 2 is 21, 18 by 3 is also 21, so it's all equal to 21. So then the last question is, yes, I do find a pattern that they are all the same, but how many pairs do I have, right? I also need to know how many pairs. And if I know how many pairs, the solution is simply just rewrite in this way and equal to n times 21. N is the number of pairs. Right, so then the question becomes, I need to know how many pairs are between number 1 to 20, and in other words, how many numbers are there between 1 and 20. Right, so there's two ways. The first way, I can just simply count them one by one, and I would know, like, for example, if I only have numbers from 1 to 5, I can easily count them as I have 5 numbers, right? Then similarly, if I have numbers starting from 1 ended until 20, then apparently, if this is a similar question from the previous one, then I should have 20 counts. In fact, there is a formula or a universal expressions that can help you to calculate this numerically instead of count them one by one. That is, if you use the last number, subtract the first number, and then plus 1, you will get the number of counts, which is also 20, right? So this is a simplified formula. Now only works that if you are counting the continuous numbers. So what happens if the number jumps? Like, what happens if my sequence of numbers are all the even numbers until 20, for example, right? So now it's definitely not 20 counts because you see they are obviously jumping and they seems to be just half of the original series. So how do I find the pattern? I'm still using the first number to subtract, I'm still using the last number to subtract the first number. However, this time they still have a pattern that they have a constant, or they have the same difference number after number, and this difference is 2. So I divided by the difference and still plus 1, and I will get 18 over 2 plus 1, which is 9 plus 1, which is 10 counts, right? It's what we guessed at the beginning, right? So here I'm going to spend more time in this question, and we'll go quick in the next few questions later. So here you would better memorize the conclusion that how to count a number, how many numbers that coming from a series of number. So universally speaking, if I have a sequence, let's say A1, A2, A3 until AN, and they have the same distance or the same difference between the neighboring numbers. Let's use a symbol d. D can be any number. If they have the same distance or the same difference between each neighboring numbers within this series, then the number of count will be still, we use the last term, subtract the first term, right? If we, to borrow the similar idea from the example we just saw, then it should probably divide it by the distance or divide by the difference, and then plus 1. So this will help you to find the number of counts from a series which has a constant distance. Now if we go back to our original question, that's like, remember I want to find how many pairs are there coming from the series, and then it's equivalent to find how many numbers coming from this series. And I know the first item is 20, the last item is 20, the first item is 1. Their difference is 1 because the numbers are increasing 1 by 1, and then based on this formula I should plus a 1 at the end. So it's 19 plus 1, so there's 20 counts. And 20 counts equals 10 pairs, right? Because eventually I want to solve this by knowing how many pairs. So then this will be 5 times, like remember, we factor out the number of 5, and then we have 1 plus until 20, which is how many pairs? We have 10 pairs times the pattern of every number, that the first number plus the last one, the second one plus the second last, third plus the second last, third last, always equal to 21. So then this is just 5 times 210, it's 10, 1050. So basically, this type of question, you would try to find the common factor at the beginning to see if you can simplify by factoring out the factor first. And then if you're left with a series of number, then you need to observe whether it is a series that with a constant difference term by term. In that case, you will very likely to find a pattern of the summation, and will be able to find the number of counts or number of pairs coming or follow this pattern. So eventually your actual solution is going to be very simplified in this way, and you will be able to get the answer easily. Okay, now let's see the next question. So this question, it's also asking for taking the sum of a series, but this one, first of all, there's no further factor that can be factored out because it's just continuous series of number. And you will see that it's starting from a negative number and then keep decreasing to 0. There's actually will be a 0 in the middle, and then keep increasing back to 97, 98. So obviously, if I have a minus 98 here and positive 98 here, they can for sure be cancelled out, or the sum will be 0. And similarly, negative 70, 97 plus 97 is also 0. So this means I can grouping the numbers starting from minus 98 and then cancel out numbers pair by pair. In this time, I don't even need to know how many pairs within here, because they will be all cancelled out until you're getting close to the number of 0. Maybe I can write 2 more terms, right? So they will be symmetrically cancelled out 1 by 1, and then left a 0 in the middle. So then this can be easily simplified as minus 100 untouched, and then plus 0, and it's all zeros. and so that it will be just equal to minus 100. Right, okay, let's see the next one. The next one is taking the summation from negative 39 to negative 37, negative 35 to negative 1. So it's a decreased, well, it's a changing series with negative numbers, and the difference is by 2 or by negative 2. So first of all, maybe it's easier to simplify the question by factoring out the negative sign. So by taking out negative sign, equivalent is equivalent to taking out a common factor of negative 1, so that your question becomes the summation of all the positive numbers from 1 to 39. Now you probably will see the pattern that, okay, so then you can see the pattern that if I'm adding the first term with the last term, and then second term with second last term, third term with the second third term, I am able to find the pattern that the summation or the outcomes of each summation of each pair is the same, right? So then this becomes a similar question as the previous one, that the last thing I need to find out is how many terms I have here, or how many pairs that I have here, right? Now, if we just skip to the known formula, how many numbers or how many terms do we have here in this series? So I know the last number is 39. I know the first number is 1. I know the difference is 2 and plus 1. So this would be 38 over 2 plus 1. That's 19 plus 1. So there's 20 numbers. Right, so I have 20. Let's copy down negative 1. And then within here, I have 20 numbers, which is 10 pairs. And then the summation of each pair is equal to 40. So it's negative 10 by 40. So it's negative 400. Okay. Okay, so the next question we see this expression. So it's a mix of addition and subtraction. So we have 100 minus 98 plus 96 minus 94 plus and minus. So keep plus and minus for all the even numbers from 100 to 2. Now this time we're still going to find a pattern, because we're not going to really doing the adding or subtracting one by one, right? So this time the pattern seems not coming from the first time to the last term, or the second term to the second last term. The pattern seems coming from the two neighboring numbers, right? So if you just simply breaking them together or grouping them together, you see that it's, first of all, it's this plus minus sign changed under a pattern, and then the difference between the two neighboring numbers also is decreasing with a constant difference. So basically speaking, the difference between every pair of the neighboring numbers equal to 2, right? So 100 minus 98 is 2, 96 minus 94 is 2, until the last term, 4 minus 2 is also 2, right? So then our last step is to figure out how many 2's are here to be added up, right? So then again, like, I want to know how many pairs are there. It's equivalent to know that how many numbers are there from the original question, and I only need to know how many numbers. So regardless of the plus minus sign, I just need to know how many even numbers are there between 2 to 100. And again, remember the formula that we just derived earlier in this class, that we know that if I take the last term subtracting the first term, divided by the difference, which is 2, increasing by 2, and then plus 1, I will know that this is 49 plus 1, so there are 50 numbers, and 50 numbers means there are 25 pairs. Right, so then back to here, this means each pair give you the result of 2, so I have 25 such pairs, multiplied by 2, I would know the final answer is 50 to this question. Okay, so the next question, if we know that the product of 37,037 times 6 equal to 222,222, what is the value of 27 multiplied by this 37,037? So again, like you're not going to really just do the long multiplication by yourself or not using a calculator, but we can use the known condition that given at the beginning of this question to see if we can convert or easily convert the unknown question to the known part. And I guess this would also be one of the essential idea when you solve a mathematical problem, that you always trying to convert an unknown question to several known conditions. So first of all, just by checking the number 6 and number 27, if 27 is a multiple of 6, then I can solve this question right away by, like, let's assume it's not multiplying by 27, it's multiplied by 12, then it's simply the 2 times of the number 6, so then your result will be also simply 2 times of the original condition. However, it's not the case in this question, so it's a little bit complicated. But from here, you would still see the common factors between the number 6 and 27. So for example, let's see, so number 6 is 2 times 3, and number 27 is 3 times 3 times 3, right? So you all have the common factor of 3, but there's a factor of 2 is not a factor within the number of 27. So which means if I can divide it by 2 and keep the common factor of 3, I might be able to simplify this question. So for example, coming from the known condition, if I divide it by 2 on both sides of this equation, we'll get this divided by 2 is 111,111 equal to, nothing changed to the first term here, and then 6 divided by 2 becomes 3. We're not completely solving this question, or not completely simplify this term, but we can leave it here for now, because now we do have something that is comparable. So which means if now I want to know what is the answer of this number multiplied by 27, it's equivalent to first defactorize the number 27 to be 3 times 9, right? Because 3 times 9 is 27. Now you can see that the first two items is coincide to this known condition, or the converted version of the known condition. So which means I can just plug in the known results of the product of 37,037 times 3 is 111,111, and then I have this 9 left over, but you can see up to here it's very clear and straightforward. So 9 times 1 equal to 9, so it's not even need to move one digit forward, it's just 999,999. Right, so in this way, you're just converting your known condition and plug into the unknown question. And in this case, you don't even need a scratch paper to solve this problem. Okay, so the next question. So what is the product of 40 plus minus 10 times 36 plus minus 9 times 32 plus minus 8 until the last item, which is minus 40 plus 10. And here the the pattern, you don't need to guess the pattern. The pattern is also given as part of a condition of the question. So the pattern is that the first number, you see you have 40 plus minus 10. So the first number is decreased by 4, right? You see the in the next bracket, the first number becomes 36, and in the next number becomes 32, and it should then becomes 28, and until keep going until the last term is actually negative 40. All right. Now the second number is increasing by 1. So if you start from minus 10, the next number will be minus 9, and then minus 8, minus 7, until the last number is 10. Right? So, okay, so there's one way that we can try to solve it is that, well, by knowing the difference, I can first find the pattern of each product, like 40 and minus 10 is 30. The second one, which is 27, because this number is keep minus 4, and this number is keep plus 1. So if you sum this together, the difference is always negative 3, right? So I don't even need to do this calculation, but I would know that this is 27 minus 3, which is 24. And keep going until minus 30. So this is one way, is to multiplying them together. This is the only pattern you can see only from here. But now, keep in mind that we're not doing the summation unlike the questions we had before. If we do summation, we can find a pattern and we can convert it to multiplication. But here it's already asking for the multiplication of each term. So this seems not going to simplify your work too much. So you need to looking for other patterns. Now, as this number goes down, you would see that they probably will cross, like on the number line, they'll keep moving to the left-hand side until from positive 30 to negative 30, which means you're likely going to pass the number of 0 or coincidentally reside exactly on the number of 0. So let's see if it ever gonna reach the number of 0, because if any of such item is equal to 0, then the problem is solved. It's a product. The product must be 0, right? So is there a chance that this number equal to 0? So in order to have such number equal to 0, let's assume that we moved x steps from the first item. Note that this should be the same number of steps moved for the second number in order to appear in the same pair, right? So which means I have 40 minus 4x, assume I moving x steps later. And I have minus 10 plus x. Right? And I want to know if this number can be 0. Right? Which means if there exists an x, or x can be solved from this equation, then there exists a certain number of x that can make this 0. Right? So if I'm regroup my numbers from here, note that here my assumption x is the number of steps, so x must be an integer, and actually positive integer. So which means if I cannot, even if I solve this equation, but if I cannot solve the x as a positive integer, which still means that it is not possible to get a term that exactly equal to 0 in a integer number of steps. And here clearly I can solve x equal to 10, which means after moving 10 steps, I will have exactly one number over here that this number is, if x is solved as 10, this just happen to be 0, and the second number minus 10 plus 10 is also 0, and 0 plus 0 is 0. So eventually the product will equal to something multiplied together with at least one term equal to 0, so eventually it will equal to 0. Okay, let's see the last question. Here we define a new operator, let's call it circle or check. So this is a brand new operator. It's neither a plus or multiplication or subtraction, so it's just something that we can define arbitrarily. So for example, if we given any number a and b, if we define the new operator a operating b to be a plus ab plus b, let's try to prove the following couple conditions to see whether this new operator it is still commutative or also associative. So for example, before we get into this question, the operator simply means, for example, if you have operator like plus sign is one operator, you have this plus operator, you would have 2 plus 3 equal to 5, or multiplication is an operator, so 2 multiply 3 equal to 6, right? So these are the commonly used operator like subtraction, multiplication, but we can define any operators just given under a given condition, right? So for example, this can be any operator that can be defined in any way that I like, right? But it doesn't mean that it automatically satisfy all the conditions, right? So here the question is really to check that this specific operator that I defined over here still satisfy the conditions of commutative and associative, right? So for example, this operator means if I have 2 operating with 3, it will be 2 plus 2 times 3 plus 3, which will equal to a number that is neither subtraction nor multiplications. But first of all, let's show the commutative, right? So basically, in order to show commutative, we need to prove that, right, A operating B should equivalent to B operating A, right? So this is to prove this, right? So then let's just start from the left-hand side. If I have A operating B, right, then this is just copy down the given formula from the question, right? And then let's check the right-hand side. So left-hand side is no further simplification needed. Let's see right-hand side. So right-hand side is B rating A. Well, here this might be confusing because A and B are just notations. You can either write it as A and B, or if you want, you can also replace this by X and Y. This is really just tells you the locations of each number should be presented. So for example, instead of writing A and B in this order, if now I'm trying to solve the B operating A, which means B will appear in the first position over here. So it becomes B plus B times A plus A, right? I'm just simply plugging in plug B into the position that A has and plugging A to replacing B here. Now, one more step from here. Now, because we know that for multiplication is commutative. So A times B times A is equivalent to A times B. And then we also know that addition is also commutative. So a plus b equals b plus a. So then this is a plus a, b plus b, right? Now up to here, this expression is exactly the same as the expression that we derived from left hand side, so that it proves that the left hand side is equal to the right hand side. So we proved that a operating b is equivalent to b operating a, and this is commutative of this operator. Okay, so the second, to prove associative, it is actually the same way, or the similar way, that this means we want to prove, if you still remember, the commutative of multiplication is what? A times b times c equal to a, b, and then c, right? This is multiplication. So for this new operator, the associative can be written as the same way. So basically we want to prove b, c equal to a and b first, and then c, right? So the same, we'll start from the left hand side. The left hand side equal to, I'm going to put on hold of the first operator. It's copied down as the same way because I need to calculate the numbers within the bracket first according to the order. Right? So b and c. So this would be b, this would be c. So this is b plus b, c plus c, right? And then second, we can consider all the numbers within this brackets as one number, and then this number is operating with the number of a. So which means when you plug this in, you plug the whole term. Well, if you couldn't understand in this way, you can replace this as y, and this is replaced as x, and you just simply plug in the value of x and y and back into this formula, right? So then a plus the multiplication of the two terms, which is a times b plus b, c plus c, and then plus the second term, which is this term, b plus b, c plus c. And then this can be simplified as a plus ab plus ab, c plus ac, and then plus b plus bc plus c. And then I might just reorganize this a little bit to put the single item in the front, a plus b plus c, and then double digit the next ab plus ac plus bc, and then I have one term abc. So this is your left hand side, right? And then I need to check what is my right hand side, and to show if they are equivalent or not. Okay, now let's check the right hand side. The right hand side of what we want to prove is a operating b operating c, right? So similarly, we're going to open this bracket first, right, to calculate the terms inside this bracket, and this is simply a plus ab plus b, and with c unchanged for now. And then again, similarly, to apply to operating this, we can consider the whole thing in front as one item, and then the second term as the second term, and then you can still plug into this, so it's still the first term plus the product and plus the second term. So it's the first term plus the product of the two terms, product, then plus the second term. Okay, so then what we're gonna do is then just to simplify the whole expression first and then regroup them in order. So I'm regrouping the single item first. I have A plus B plus C. I have double digit items. I have AB plus AC plus BC. And I have one straight digit item, ABC. All right, so I have right hand side equal to this, and I have my left hand side equal to this. And you can see that they are the same. So which means up to here I proved that my left hand side equals to right hand side, such that this equation is true, such that this operator is associative. Okay. Okay, so next we're going to check within this operator if there exists an identity number under this operator. So identity means, like again, in multiplication, identity means any number A times 1 equal to A, then number 1 is identity of multiplication, right? Or in addition, 0 is identity in terms of addition. Now we're looking for the identity in terms of this operation, or this operator. So which means I need to know, given any number, for any number A, I want A operating this unknown I still equal to A. So let's see what really looks like on the left hand side. So this means A operating I, back to the given formula, is equal to A plus A I plus I. And I want this to be equal to A. So I can first just cancel out these two terms. I get A multiply I plus I equal to 0. And if I factor out the common factor of I have I times A plus 1 equal to 0. Now we can see that if A is any number, then in order to make this equation, or in order to make your left hand side equal to 0, the number I must be 0. And only if, when I equal to 0, I is the identity, or 0 is the identity of this operator. Okay, so then we find the identity of this operator. It does exist. So let's see if the inverse or the reciprocal also exists with respect to this operator. So that means, if there exists a number operating with number 1 or equal to identity, like for example, in multiplication we have, if we have a number A times 1 over A equal to 1, right? So 1 over A is the inverse of A, right? So, or in numbers, if I want to find the inverse of 2 in multiplication, then 2 times 1 over 2 equal to 1, so which means 1 over 2 is the inverse of 2 with respect to multiplication, right? Now we have a new operator instead of multiplication, so we want to know if there exists a number x that is the inverse of 1 with respect to the identity. Now, from the last question, we already saw that there exists an identity and identity equal to 0. So the question equivalent to show that whether we can find a number x operating 1 that equal to 0. So the left hand side x operating 1 is x, right, plus the product of 2 plus the second term, which is 1, equal to 0. And this means we want to have x plus x is 2, x plus 1 is 0, right? So then it's just solving from this equation that x equals minus 1 over 2. So minus 1 over 2 is the inverse of 1 with respect to this operator. And we can verify that. Basically, if this is a inverse, then the product or the operating should equal to identity. So if negative 1 over 2 is really your inverse, then this operating 1 should equal to 0, right? Let's just verify, because we already solved it. Let's verify it. So this equals negative 1 over 2 plus negative 1 over 2 multiply the second term, and then plus the second term. So this is negative 1 over 2, right? This is negative 1 over minus 1 over 2, and then plus 1. So it becomes, this together is minus 1 plus 1 is 0. So we just proved that our solution is correct. So that's all for this question.